Hello everyone. So today we are going to do this problem called remove the k, a linked list problem called remove the k node from the end. So let me explain this one. It is a bit simple. So we are given two inputs. One is a case integer k is equal to 4 and the other one is a linked list. So head will be pointing to the first one. So what we have to do is we need to remove the fourth node from the end. So so for example here k is equal to 4, so we need to iterate first, second, third, fourth, and we need to remove 6. So in the end we should be having 0, 1, 2, 3, 4, 5, 7, 8, 9. So this is what we have to do. So we just need to remove 6. So how we can go about that is, so first thing, so brute force approach. So what we have to do is first we need to get the length. So one second. Yeah. So step one, the brute force approach is to get the length of the linked list. So what we have to do is we need to start from here and iterate till the end. When the when when this one is pointing to null, so we should go on until .next is null. So and then after getting the list, so let's call this one as len. Okay, next. So step two. So we need to, so after getting the length, we need to do len minus k. So do len minus k. So in our case it will be 10, since this length is 10, and then we do minus k. K is now 4, so we do equal to 6. So now we got len minus k is equal to 6. So now this one, now the 6 is equal to the index to be to be removed. So 6 is the index to be removed. So if we start from here, 0, 1, 2, 3, 4, 5, and 6. So this one is the index to be removed. So but then the thing over here is the actual index to be removed. We need to, we can't come till 6 and then remove this up. So we need to come till 5 and then we need to remove this one. So the actual index to be removed is equal to is equal to this index to be removed minus 1. So index to be removed minus 1. So yeah, so after we come till here, so step 3 is to remove the move to index to be removed. We need to move till here, move to actual index to be removed and remove the index. So these are the steps what we have to follow. So let's put that into code. So first thing, we need to get the length of the linked list. So step 1, let's get the length of the linked list. So let's linked list So we are just assigning this one. We don't, the head doesn't change. So let's initialize a count int count is equal to 0. Let's make it 1. Okay, let's make it 0. So next, so while head dot next, let's keep it as head is not equal to null. So we gotta do count plus plus. Next we have to do head is equal to head dot next. So yeah, so what we are doing over here is we are iterating until head dot next, until head dot next is not 0. I mean head dot next is not null, so we're coming here. Again head dot next is not null, we're coming here. Head dot next is not, the head is not null, we're coming here. And then we do head dot next, head is not null. Then we do head dot next, head is not null. Then we do head dot next, head is not null. So head is not null, head is not null, but here head is null. So we come, so when head is null, we come out, and then we should get the count as, so let's get the count. So system.out count is equal to plus count. So let's see what this one gives. So ideally I should be getting a 10. Okay, so this one is correct, so count is 10. So the next step what we have to do is do length minus k. Also let's keep it length. So we need to index to be removed. LinkedList. Wait, it's not linked list. So int index to be removed is equal to len minus k. So 10 minus 4 will give me 6. So int actual index to atbmi, actual index to be removed is equal to index to be removed minus 1. So now we need to go to step 3, move to actual index to be removed. Let's say index actual, let's just call it actual index since we're not removing this one. let's just call it actualIndex. So we are calling this. So since we have to remove this one, we need to come till 5. So we are just doing actually index to be removed -1. So now, so let's do that. So now, so this should be current node. So index to be removed. So current node is what we have, and then here is it. Okay, everything seems to be correct. Let's just put this back. So it will be pointing to somewhere else. Now current node, we just want current node to point it back to head. So let's do that. So now current node is head. So while, so we need to come till this one. So just keep one thing, index is equal to 0. So now we need to come till this one 5. So once we come till there, how to come? So let's keep one index is 0. So while index is not, while index is equal to AI. So here we're doing to remove index to be removed. So now this index it is not equal to null. So if index is equal to index to be removed, so then remove this, remove index to be removed. So Now what we have to do is current node is if not we move keep moving current node dot next. So now we are here. So linked list. So now if we enter this if block, we are currently over here. So linked list. So node to be removed is equal to current node dot next. So next node to be removed is current node dot next. So you get this node to be removed. So current node is equal to current node dot next must point to current node dot next dot next. So what this means is we are here this current we are in this current node over here. Current node dot next is this. Current node dot next is this one. So we need so this next is pointing to 7. So current node dot next. So and then we can make node to be removed is equal to null. Next. So here current node is not equal to null. And yeah, this let's see if this works. Okay, 1 second. Okay, I'm getting errors. Where is it getting errors? 10. Okay, current node. Okay, what's happening? It's not removing anything. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Why is it not? Let's see. What's the index? Index is equal to plus index. It's not coming to this if condition also. Okay. iterate.index. I forgot to do index plus plus x is equal to, I forgot to increment index. Java 24. Okay, so here some issues are coming. But let's check if index is correct. So index is 6. Okay, I should be stopping at 5. Index is equal to AI. Okay, now null pointer and stuff is coming. Okay, so now as you can see, it has passed the test cases, but it is, I think I know where it is failing. It is failing when, okay, it is failing when the head node is to be removed. So for example, if k, let's take a new one. So what if, okay, what if k is equal to um, what if k is equal to 4 here? 4, first 2, 3, 4, 5, 6, 7, 8, 9, 10. So k is, what if k is 10? So if k is 10, so we need to remove 0. So in that case, we will get length minus k. If we do length minus k, we will get 0. Right? If we do this one, we will get it 0. But actual index to be removed is equal to, so index to be removed is 0. But actual index, I'll just call this actual index. Actual index is equal to index to be removed minus 1. So it will be 0 minus 1. So which is now equal to minus 1. So that's why, so minus 1, there's nothing called minus 1 here, right? So if we go back to code, we will get index is equal to minus AI is now minus 1. So this condition will never be true. So in that case, we will just add one separate if condition here. So if AI is equal to minus 1, so here we need to remove head. So if we have to remove the head, what we have to do is, first we have to, so head is now here. So we just, first we need to change the value of head. So head is equal to head dot, so head is equal to head dot next dot value, and next head is equal to, so next thing what we are going to do is head dot next must point to this one. So head is equal to head dot next dot, wait, head dot next should point to this one. So head is equal to, so head dot next, so head must point to head dot, So let's see. So head dot next is equal to head dot next must point to, so head dot next is heads dot next must point to head dot next. Next, let's see if this works. Head dot value okay. Head dot next must point to 1. Head substitute we need head dot next must be equal to 1. So how to make it point head dot next dot next. Heads next method heads next must point to head next dot. Okay, so what we did is heads next, this one must point to head dot next dot next. So head should be here and heads next should point to 2. So that's what we have done here, and all test cases are passed. So but this is not a good method. Why? Because we're iterating once to get the length, and then again we're iterating the same array to remove the remove the index. So now what we want to do is we need to iterate only once. So in order to iterate only once, there is one more method, like a more efficient method. So what I'll tell you what that method is. So for example, so for that what we need to do is uh, just make it next. So for that one, so what exactly we do is, so we create two pointers. One is the left pointer, other one is the right pointer. So what we do is, so for example, case 4 over here. So we create, so we have two pointers, right? So we do go one pointer, we make it point here, and the other pointer we go till 0 1 2 3 4, we make it point to here. So now what happens, so this is the first step, we need to make these two pointers point here. So and then together we need to keep iterating until this one second pointer points to a null. So together, so what happens is, so first will be, so we need to start iterating now. So take this one over here, so move it here, at the same time move this one, move this one also here. So so now this, we move this by one, we move this one by one. So next again continue this one, move this one here, and next move this one here. So now we did this by one. So next again move this one by one. So next again move this one by one. So again by one, and next again move this one by one, and next again move this one by one. So yeah, again this thing is not pointing to null yet. So now again move this one by one. Again move this one by one. So it's not pointing to null yet. So next again move this one by one, and we move this one by one. So now it's pointing to null. So as you can see, the second pointer is pointing to the element which has to be removed. So in one iteration only we found out everything. So 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 yeah, so this is a better method. So uh, and also the time complexity will be O of n, because will be where n is the, like, the, the total number of elements. So because at least at some point this this one pointer would have iterated through all of them. So so time complexity will be O of n, where n is the total number of elements, and the space, we are not creating anything new or something, so it will be O of 1, space will be O of 1. Okay, so let's put these steps here. So what are the steps? So step, step 1, create two pointers, LP and RP, left pointer and right pointer. So iterate RP till k. So move RP till k. So if k is equal to 4, move till 4. So and next step 2 is to move both pointers to the right until current node dot next is equal to null. So guys, we need to stop at current node dot next is equal to null, because we don't, this is the index to be removed, but we want to come only till here. Only if we come here we can remove this index. So we need to stop over here itself. So it's actually not current node is null. We need to check if current node dot next is null. So again, going back, we check, if we check, we come till here, current node dot next is not null. So next we come here. Here we see that current node dot next is equal to null. So we'll be stopping here and here. So I missed that to explain. So yeah, current node move pointers until current node dot next is equal to null. So step 3, remove node left pointer dot next move node. So remove this node, remove node pointing to lp.next. So these are the steps. So this is much simpler to implement also. So let's go back. I'll just comment all of this. So what we do here is, okay, linked list is equal, linked list lp is equal to current. So is equal to, for that I'll just put this current node is equal to head. So it's always safe to put this, because you should not change the head. Put this into this temporary variable, let head always point to head only. So current node, so linked list rp is also equal to current node. So now, sorry. So now what we have to do is the step to move, create iterate rp till k. So while we have index is equal to 0, so while current node is not equal to null, so while it an index is equal to when index is not equal to k, come inside. So if this index is not equal to k, rp is equal to rp.next. Next after this, index plus plus. So what happens here is, index is not k, rp is equal to rp.next, index plus plus. So it should be k minus 1. not be the actual k. Wait, I'm getting confused. So k, RP should go till k. So while index, yeah, I think this is correct. So now we'll just check system.out.println rp.value is equal to rp.value. Let's see what rp.value is in our case. It should be it should be 0, 1, 2, 3, 4. It should point to 4. RP should point to 4. Okay, RP is correct. So we'll handle that head case later. So now we have RP pointing to the right one. So we need to move both pointers to the right until current node.next is equal to null. So what we have to do is while rp.next is not equal to null, let's open this. While rp.next is not equal to null, while rp.next is not equal to null, is not equal to null. So we have to do lp is equal to lp.next, and rp is equal to rp.next. So in the end, lp, let's check out lp now. lp dot value must now point to 5. Okay, so it's pointing correctly. So we just need to remove that part. So lp dot next is equal to lp dot next must now point to lp dot next dot next. means what I did is, so we are here, so lp.next must point to this one 7 .next 7. List. So node to be removed is equal to lp.next. So to next, so not to be removed. So we are now at this point. So we are now at here. We are now here. So now we need to. So what we did is remove this one. So linked list to be removed is this one. So that is lp.next. So this is lp. So lp.next is this 6 and next lp.next. So this one's next must point to this one. So that's why we have written. So this is lp right now. So lp.next is nothing but the node to be removed. So this one is what we have done here. So and then lp.next, this lp's next must point to .next. So it should point to 7. So that's why we have written this one. So you can then export node to be removed. You can just make node to be removed point to none. So let's see if this works. Okay, so I think only the head one, yes. So only the head one is remaining. So when head is there, what happens is, so let's take this text. Okay, so just imagine. So now for that one, we'll take k is equal to, so first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and tenth. So if k is 10, we need to remove 0, right? So as per the steps, if we go, so create two pointers lp and rp. So move iterate rp till k. So k will now be, so we'll be having lp here and rp will be here. So because we need to iterate rp till k. So now move both pointers to the right until currentNode.next is null. So currentNode.next is already null. So this head can be removed. So remove, so we need to remove the head, right? So for that one, what we have to do is, so we just need to remove the head. So what is the condition for that? So if, okay, so So I'm thinking, so if linked list dot okay, so what is the condition to when do we come to know that we remove the head? When do we come to know that we are at the head? So we can come to know we are at the head. So here we have removed it. So what exactly? So why it is failing when it is at head? Because here rp.next lp.node So let's check out this. So in our case it must point to 0. Okay, so at 46 it's throwing an null pointer. So rp.next is not equal to null. So we are over here. So rp.next line number 46. Where? How can it throw an error at line number 46? So rp.next is not equal to null. Print record rp.value is now 9. So what it's saying is rp.next. So rp is equal to 9. Next rp.next is actually throwing another because look at it, so still not getting rp.values. Okay, yes. rp okay, rp is null. So over here on the rp is null. Index 0 is not equal to 0 is not equal to 10. So index is so keeps on going. So here the error is happening. So index 0 is not equal to 10. So rp.next next plus plus. So what I have to do is 0 while index is not equal to k, while index is less than or equal to k. Because 1 is 0, and what is this? RP is already pointing. So, so what is causing ratio here? Index is 0 and index is so what's the value of k? So k is equal to 10. So index is not equal to k. Yes. So rp is equal to rp.next x plus plus sum. So here some condition have to change such that rp next is not equal to null. Okay, let's put this rp.next is not equal to null. Dot value put use 9 dot value is now 9. That's correct. So rp.next is not null is equal to So what is that condition when this points to an head? lp.next. Okay, if case then rp.next it goes up till then. If index is equal to not getting the connection for head. It should be the condition if is equal to okay. Now just for that one, if rp is null, I'll just remove this. Is equal to null. So currently we go by this one, rp will be pointing to null. So remove it. Head dot value is equal to head dot x dot value head dot next is equal to head dot next. That's dot next must point to head dot next dot Okay, so this is how we do it. So going back, so now when k is 10, so now we need to remove head. So as soon as we know that, so, so to remove k is 10, we go till 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So RP will be pointing to null. If RP is pointing to null, it means we have to remove the head. So that's why I've written here. So RP is null, we need to remove head. So head.value.next. So we need to remove head and then return it off. So yeah, that's the problem for remove get node from the end. And time complexity is of n and space complexity is O of 1. Oh, it's of n because we are just iterating one through each of the nodes, wherein is the nodes, and of 1 is the space complexity because one it is because like we're not creating anything new. So yeah, that's the solution.